right, everybody can hear me okay? I imagine that's a yes. Okay, everyone can hear me, good. All right, so what we're working on today, we're gonna get into ratios. There's a lot of good things in the realm of ratios that we can talk about. You know, first and foremost, you know, one of the important things with ratios is the idea that it can show up in many facets on the test. You can see it in regular problem-solving questions, of course. You can see it in a lot of different data insight stuff. So things that encompass a lot of different types of questions that can exist on the test. So that would be the first thing. Second, there's a lot of cool kind of things with ratios that mix with percents, mix with fractions. So a lot of the stuff that you're learning when you're learning about ratios can carry over to other question types. And I want to talk a little bit about that today if we have some time, and the idea that sometimes plugging in numbers, plugging in values is a really great way to deal with ratios. So let's get that going. Just going to get this open. So the first thing I just want to quickly talk about is how to deal with ratio multipliers. That's a good way to handle a lot of different ratio questions, especially the more basic ones. But what it's doing is it's putting your relationship into one variable, right? So if you're in a position where you can determine the value for that variable, well, then you can get a value for your ratio. Because remember, ratios themselves don't necessarily give you quantities, right? So ratios are just giving you relationships, but you don't know the actual values until you have some sort of equation to help you determine that quantity. So here's what I mean. I'm going to give you this question to start. And it's not anything crazy. And remember, this whole concept too can be relayed in data sufficiency as well. You know, once you know you have a ratio, if you can get that multiplier through a statement, let's say, that'll make the statement sufficient. So that's another way to be thinking about this. So let me get the first question open. And as always, I'll put the first question up. You guys do it out. Put your answer in the chat box, and then we'll go from there. All right, so take a look at this first one here. And then put your answer in the chat box. Okay, cool. Give this a shot here. Give you guys a minute. All right, so I see some good answers here. Were you guys essentially using ratio multipliers here to solve this out? I imagine the answer is probably yes. And that is a good way to deal with this. So we've got lions, let me do, tigers, bears, we're talking 3x, 8x, 10x. So now, remember what I said before, initially you don't have, it's all about equations, right? To be able to solve for the x multiplier, to be able to get the actual value. Well, this is actually an equation with tigers and lions, 20 more tigers than lions. So tigers is equal to lions plus 20. We see tigers is represented by 8x. Lions is represented by 3x. Bring the 3x over, 5x is 20, x is 4. So we have what we need for x. How many bears are there? 10 times 4. So this isn't bad. The one tricky thing is making sure you're actually solving for what they're asking for, because that's another kind of tricky component to this. So just be on the lookout, you know, for that as well. So yeah, nothing too crazy here. Hopefully, you know, you guys think this is decently straightforward. I want to get into, as I said, some other stuff where we're talking about plugging values as well. So let's see here. The next one I want to do, so this is not going to deal with ratio multipliers, but this is going to deal with some other component of ratios that's fun to teach. Just pulling up the question. So yeah, remember, not all ratios is dealing with multipliers. There's other stuff happening where you're getting things in terms of the same variable or you're subbing in. So this question here, you can solve a number of ways. I'm going to teach you guys how to plug, but if you solve it not plugging, it's certainly not the end of the world. That's for sure. All right, so one question as these answers start to trickle in, as you guys are solving these, are you feeling like your method is I'm getting everything in terms of one variable, or I'm getting everything in terms of one variable, then I'm going ahead and I'm subbing in? Like what's the process here looking like for you? Are you using real terms? Are you not using real terms? So on and so forth. Because you can kind of do a little bit of both. Like you do have to set up this equation here, 1/2 convertibles is equal to 1/5 total, right? And 1/4 sports cars is equal to 1/8 total, total being the common term here. So you could say, hey, I'm going to make T 40 because that's the LCM of 5 and 8. So it evenly divides. And again, this question isn't horrible. So, you certainly don't have to plug in, but it's something that can work well. So then you have 1/2 C is equal to 1/5 of 40, which is 8, or C is 16. And then 1/4 S is 1/8 of 40, or 1/4 S is equal to 5. S is equal to 20. Then you do this out. Ratio of sports cars to convertibles is 20/16, which is 4/5 or 4/25. Now, did anyone take this method here? Or did you guys just get it into one variable and have that cancel? You did. Perfect. Okay, I agree. It's a good method. I like it. It's not something that I did when I first started out dealing with ratios and percents. But what I'm realizing is if you can be quick at picking these numbers, it'll make your life easier. And as I told you, these are all related to percents and fractions and all that stuff. And that's the situation we're finding ourselves in here with this next question. Notice it's telling you to solve for the fraction. Well, that's fine. It's no different than if you were solving for the ratio. So that's really important to see here. So take a look at this. All right, I see some good answers coming up here. So what we need to do is we first need to make 4 equations. Now, did any of you guys plug in real numbers after making your equations? So when you have, okay, there's 1/4 as many everything as plane. So you could say 1/4 times plane is equal to everything. You could say 5 times as many plane as raisin. So plane is equal to 5 times raisin. There's an equal number of onion and raisin bagels. So from here, did you guys go ahead and maybe plug in some real values after, you know, essentially doing out these equations to start? Because another thing too is, like, you can actually rewrite this to say P over 5 is R, and then what you end up doing is you use a real value for P, right? So what ends up happening here is you say, okay, I'm going to make P 20, for example. So if P is 20, okay, everything would be 1/4 of that, which is 5. So you have that. Your P is 20. Raisin would be 1/5 of that. That would end up being 1/5 of 20 is going to give you 4 for raisin. So that's done there. Then you have onion equals raisin. So of course, onion is equal to 4 as well. So we kind of have what we need there also, right? So rewriting this, P is 20, everything is 5, raisin is 4, right? And then onion is 4 as well. Well, that's pretty much all we need, right? So plain bagels and raisin bagels are what fraction of the total? We add these together, total 20 plus 5 is 25, plus 4 is 29, plus another 4 is 33, and we need plain plus raisin, that's going to be 24. So that's going to give us 3 goes in this 8 times, 3 goes in this 11 times. It's going to be 8 over 11, which is answer C. Now, did you guys, yeah, it looks like you guys did something similar. Is that right? Because, yeah, I mean, it's a very, very good way to deal with this question for sure. All right, so that's something important. I hope you guys can kind of appreciate, you know, the method used here as far as plugging into these ratios and fraction problems is concerned. I find it to be very helpful. It's something that, you know, when applicable, you should try to do it for sure. So yeah, just kind of keep it as part of the process of what you're doing if you like it when you're dealing with these types of problems. Look, if you don't like to plug in and you feel just as good with the equations and whatnot, like, yeah, that's fine too. But find a process that works for you. You're going to get the same answers either way, just a matter of what's more, you know, efficient for you. All right, this is something different, so take a stab at this and then we'll talk about it. All right, so these are called three-part ratios. A good way to deal with them is getting things into terms of the LCM based on some of the terms in the ratios. So for example, what we have here is red to blue to green, or we have red, blue, and green rather. And then what we're doing is we're coming up with, they're going to give us, they're not going to give us, they give us two different ratios at this point, and then it's a matter of how we deal with it, right? So we have red to blue, and we don't even have to use multipliers here. We can just write the actual numbers. It's 5 to 6. Red to green is 4 to 3. Okay, so the whole purpose of that is now we have our two ratios, but there should be something kind of clear here. And that's the idea that we have a red which has a 4 attached to it and a red that has a 5 attached to it. So now all of a sudden this becomes 20 to 24, and then this one becomes 20 to 15. Now, does that make sense to everybody how that's good, you know, looking right there? Because what we've done is we've had to make them the exact same. So the next thing is, well, what could be the max number in the box? Well, it has to be a two-digit number. So we have 24 plus 20 plus 15. The problem is if we go one step higher, what we're going to end up having here is 48 plus 20 plus 30. And as we can see, that's not going to be a two-digit number. So because of that, or excuse me, we have 28 plus 48 plus 40, not plus 20, plus 30. That's not going to be a two-digit number, so that's restricted. It's out. So that means the minimum number of blue worms in the box has to be 24. There's no other option around it. Now, a side note that I want to mention is that when you're in this situation with this type of problem, they're going to have to give you something that restricts the information, okay? So it can't just be a situation where, you know, they're basically saying to you, you know, this could go on forever. There has to be something, especially in data efficiency. They'll say like, you know, the number of men is less than 30, or the number of children is less than 60. Something like that will provide restricting information so that you're in a situation where you'll be able to come up with an answer, usually. Now, I want to do one more like this, then we can do some Q&A. So here, let me pull this one open, and then we can chat for a minute if there's anything anyone wants to chat about. All right, do this one out. This is data efficiency, so of course the answers are not going to be included, but I think you understand what's going on here. Okay, so we have some given information, not much actually. We just want to know if the people on the science team is greater than 16. Statement 1, students are in the science to the total number of students is 3 to 4, or in the math, sorry. So science to math, we can actually do it this way, is 3 to 4. That's not going to be enough information, right? No way. That's just giving science to math, no real quantities there. So if we do our grid, we get rid of A and D. Statement 2, the ratio of the number of students who are on the science team to the number of students who are on the chess team is 5 to 2. Again, not enough information, right? However, if we look together, we can but we can determine that the minimum science has to be 15 or some multiple of 15. So can we say without the shadow of a doubt that the number of students who are on the science team is greater than 16? We can't, because there could be 15. That would be an answer of no. There could be 30. That would be an answer of yes. So hopefully that makes pretty good sense to everybody. All right, cool. So the answer is E. Does anyone have any questions while they're here? Questions about your GMAT? Questions about TTP? Anything really? And if you do, just stick them in the chat box. Any questions at all here? All right, well, if there are no questions, we can call it. Good webinar. Hope you guys enjoyed it. We will be back next week. Yes, coordinate geometry does show up on the GMAT. It does. People have seen it, so it exists. I know there's not a lot of it in the OG, so it seems like it doesn't, but it does at this very moment. So, all right, good stuff, everybody. We will talk next week, and thanks for coming. Thanks for participating. Talk to everybody soon.